Hi, my name is Summa. I'm making a video on proper meter usage in electronics. The first thing you're going to want to do is turn your meter on by pressing this green on button here. What you're going to want to observe is you first need to know what you want to measure. What I would like to measure is resistance in ohms. So I would make sure I have my meter leads, in the ohms section, in this jack here. So now that all checks out, the resistor I have is a 33K or 33,000 ohm resistor. So I have mine on the 1,000 scale. Now what you're going to want to do is, the leads I have are alligator clip leads. So I clip my alligator clip leads on here, onto my resistor, and I'm going to make sure as that my hands are not touching the leads, giving me an inaccurate reading. As I said, this is 33,000 ohms. 32, 33, okay. See? Sometimes it seems to fluctuate. You're never going to have perfect, you know. So what you're going to want to do is, after this, I would like to measure voltage and current. So if I were to measure voltage, what I would do is I would set this to voltage, and my preferred voltage is I would like to get 10 volts. So I'm going to set it to the 10 volt scale. Now I need to turn my cadet trainer on. That is the first step. Turn the cadet trainer on. You'll know it's on when these lights come on. I'm going to take my negative lead to the ground or negative post. My red or positive lead will be to the positive post. Now what this will give me is a reading of 10.01234, whatever, ohms, or volts. So what that means is that I have 10 volts coming from the source. Now, if I were to connect a resistor into here to find out what my voltage would be on this resistor, I would want to connect one wire from the ground and one from the positive end. And the way these are connected is they're all connected horizontally. So the way it works is that if I have my resistor here and here, because they're connected horizontally across, and that means I should get a connection. So what I would like to do is I would like to measure the 10 volts across my resistor. Now, there's no real way, or not a real way, but if you were to connect these, there's no wrong way to connect them, because they don't need a certain polarity as current would. It helps.
It's on voltage right now.
No, it's on voltage. I have it set to voltage. Now, it helps if you connect the positive lead to the side that is closest to your positive wire, as you can see here. Now I connect my positive lead to the closest positive end. I get 9.934 volts across my resistor. That's pretty much the same as the source voltage because it's the only resistor. It's not like the voltage could go anywhere else. So, now what else I could do is I could now measure current if I want, for example. So now if I go to measure current also, another real big thing to make sure you've got is that you're on the proper DC or AC setting. If this is pushed in, it's AC. If it is left out, it is DC. I'm measuring DC voltage coming from DC jacks. That's important, because if you measure AC, you'll get the wrong reading. Now, I'm going to measure current. The first step in measuring current is moving your red lead into the thing for milliamps, into the jack. Now, what you're going to want to do is, the thing with current is when you measure current, you need to break your circuit. So I would take my wire from my ground and disconnect it. Now this is when you actually do need to know your polarities. This is the negative side, and this is the negative side of the supply. So I'd put my negative lead on it. Going to put my positive lead on what's closest to positive, which is this resistor here. Now what I can do is you're going to want to have your power turned off when you do this, just in case. As you can see, the power is off on here. Now, I'm going to make sure my circuit is broken, and now what this is going to give me is a circuit where the meter is connected in series, just like as if it were a wire. Now, Lamar, can you please turn that on? What I'm going to get when I turn it on is a reading of 0.31 amps, or 310 milliamps. So you're going to measure current. Another thing you could do is you can measure AC. DC is what comes out of batteries, say for example like 9-volt batteries, D batteries, AA's, things of that nature. You can get AC voltage out of jacks in the wall, such as these. You get AC voltage from here. So if I want to measure AC voltage, what I would do is I would turn my circuit off, and I would do is I would connect it to the AC jacks. These AC jacks put out a maximum of 12.6 volts. So now, connect my resistor. Now, what I can do is I have other wire. This wire's gotten beat up after a while. And the way AC works is you can pretty much have it connected whichever way you want. I'm going to connect this here. I'll connect this other lead here. So now they're connected properly in AC. And then what I'm going to do is select the AC setting, select AC voltage, move my lead to the slot for voltage. I'm going to turn my meter on, and AC voltage doesn't really have much of a negative or positive side because it pretty much flip-flops. Like this could be positive, and then it'll switch to negative, and it'll positive, negative 60 times a second, or 60 hertz. That's what you would get out of the wall. Now connect this, and I connect my other lead, and it shows that I'm getting 7 volts AC. Now I see that I'm getting 7 volts AC, and I connect my leads to my resistor, and I get 7 volts AC. So that's how you measure AC voltage on a resistor. I guess that concludes our video on how to measure things with meters and electronics. There's key points to remember though. You need to remember, while you're building your circuit, make sure your trainer and breadboard are off, because if you're working with say if you're working with 12 volts and smaller, you won't get shocked or anything. But if you're working with high voltages, you might want to turn it off just in case. Or say if you connect something wrong, you might damage components. So what you're going to want to do, like I said, for safety reasons, keep it off. Also, you need to make sure your wire is stripped, because it needs to be a metal connection inside of, because all behind this is rows of metal. It needs to be a metal-on-metal connection, or else nothing will happen. Because if you have insulation on metal, the insulation is made to not let voltage come through here, so you don't get shocked on wires. So it's going to do its job and not let voltage come through, and your circuit won't work properly. Other things to remember is make sure everything on your meter checks out okay. Say, for example, I would like to measure 10 volts DC. What I would do, I would make sure my meter is on, I'm in the proper jack for voltage, and if I'm measuring 10 volts, I want it on this scale, measuring voltage, DC voltage, so this should be out. I'm on the DC setting. When doing current, I would... Alright, let me wrap up. Okay, I'm coming to the conclusion now. So, also, one thing for current is, you might not use it in electronics, but if you're on the current scale, and there's a 10 amp max jack, if you're doing high current, then you're going to want to use this, because this jack has a 2 amp fuse and a 2 amp max. So if you're going over 2 amps, you'll need to use this. You'll need to use this jack. If you're using under 10 and anything under 2, you should be okay here. And that concludes my meter video. Special thanks to Lamar and Mr. Pelletier for giving me this camera. And there you go, it's over.